Hello, my name is Mark Christopherson, and this is the final Explainer video 4. And my question is, the textbook gives radical chlorination probabilities as 6, 4.51 for tertiary, secondary, primary. Use these ratios to predict the distribution of products formed when 2,2-dimethylhexane is chlorinated. So there is a video or a link to a video in the comments that really helped me kind of get through this. Trying to select through the book was a little difficult, and this guy kind of ironed it out a little bit. But the first thing that I did on the left here, we see I determined the hydrogen degree. And this is also, you could compare this to what degree is the carbon is at the primary, secondary, or tertiary. Here we can see the primary. So since these are all the blue ones are primary carbons, those are considered primary hydrogens. Same thing with secondary, since these are attached to two carbons each. Those are secondary, and the tertiary actually is 3 connected carbons. And again, the primaries only have 1. I just have those circled nice. So once you have that figured out, we can determine the abstraction probability using this relative selectivity that we actually receive, which is up here. So it's 6, 4.5, and 1, respectively for tertiary, secondary, and primary. So now we get to do a little bit of math. So the first number in these columns is actually the number of hydrogens that fit the criteria for being whether it's primary, secondary, or tertiary. So we can kind of go back. So 12 here. So we have 3, 6, 9, 12. So I have 12 primary hydrogens that I multiply by 1 for the abstraction probability. And that gives me a 12. And then we'll get to this column in a little bit. Secondary, so I have 4 carbons, and that's multiplied by 4.5, so that gives us 18. And tertiary, we only have 2, the implied hydrogens over there. That's times 6, then equals 12. So when you add all of these up, you get a total H abstraction value of 42. Now to find the percentage of an extraction value or extraction percentage of any hydrogen based on whether it's primary, secondary, or tertiary, you just take the number that we got divided by the total H abstraction value. So for primary, there's a 28.6% chance that an extraction of a primary hydrogen will happen. For secondary, there's a 42.8%. In tertiary, there's a 28.6%. Now, since this isn't a molecule that's mirrored, you actually have to go and figure out how many products there all are. And there are actually 8 that I went and found. So first you find all of the products, and then I also color-coded these and assign percentages based off what we found in the second step. So the primaries, so there's only a 28.6% chance that a primary hydrogen will be selected. In this particular case, we have 4 different molecules that could be. So I would just divide 28.6 divided by 4, and that gives me 7.15. So there's a 75.1% chance that any one of these molecules will be formed. And you do the same thing with secondary. So since there's only 2 here, because there's only 2 molecules, we have a basically just divide this in half, 42.8. There's a 21.4% chance for each of these to occur. And then tertiary, same kind of thing. We have a 14.3% for each because our original base is 28.6. Divided by that. And that is the breakdown. Again, there is a link in the comment section to a video if you're having trouble with this. They helped me iron it out relatively easily and broke it down in a simple manner. All right. Thank you very much.